Let's do a little bit of continuation of where we were, and then I'm going to break away from that and get on to some last details you need for the assignment. So, Java game. Of course, it starts in the wrong window. There's my Mario. Here's a brick. And Mario runs, bumps into the brick, and it stops him. Jumps up here, and I get stopped right there sometimes. Do you remember that from last time? I tried to jump over the brick, but my collision detection isn't right, and something bad is happening. Anybody know what's happening? I didn't know either, so I had to debug it. And then after I did, I put it back because I wanted to show you how to debug it, because that's good practice. So let's suppose your code does something you don't want. Like, for example, Mario can't seem to get over the darn brick. What do you do? Yeah, there's two choices. You can put print statements in your code, or you can use the debugger. And pretty much, which way is more effective? Sometimes. For many problems, the debugger's better. Basically, the debugger lets you look at everything without having to mess with your code. However, there are some problems you can't really solve with a debugger, and there's almost nothing you can't solve with print statements. So the professor that taught me to program used to say the most powerful debugger in the world is print statements. Why is that?
Well, it can't tell you where should they like.
Yeah, if you print everything, well, then you've got a whole bunch of information, and then if you dig through that information, what you need must be in there, right? And if you knew everything, well, of course, the problem's solved. What is debugging? It basically means you don't know what's going on, and when you're done debugging, you do know what's going on, right? Debugging doesn't fix your problem. Debugging just gives you knowledge, and the secret to getting knowledge is you've got to look at it. A lot of times when people debug, they use what I call the bleeding eyeballs technique. Let me demonstrate the bleeding eyeballs technique. Whoops. Here's what you do. You open your code, and you stare at it. And you say, that seems right. And you look at the next little bit, and you say, that seems right. And you look at the next little bit, and you say, I don't see what's wrong with that. And you move on. And then you repeat until you solve the problem. How do you feel about the bleeding eyeballs technique? Why do I call it the bleeding eyeballs technique? Because, yeah, I mean, come on. You only get one set of eyes, and when you get old and they turn blurry, you know what? That's all you get. So here's my advice. Never, ever use that method. Now, having said that, all of you are going to do it because everybody does. It's what you do. Why? Because who wants to open a debugger? What a pain, right? And at some point, you'll be too lazy to open your debugger and you'll resort to the bleeding eyeballs technique. But I do want to emphasize why it's a really bad idea. So in this class, we're working on little tiny itty bitty problems, right? I mean, Mario and a square. Do you think you'll ever work at a company where they are building something like a Mario and a square? The answer is no. So the reason it's no is that was like 1982 when that kind of stuff could sell, right? Pong once made $1 million. No one will ever make $1 million off of Pong again. At least not on a home system. Maybe whoever made the first Pong on an iPhone did or something like that. But anyway, my point is this. Software is complicated these days. So think about how hard it is to find your bug by staring at your code until you see the problem. How hard is it? Pretty bad, right? Well, then you go work at a company, and this code was not written by just you. It was written by a team of 50 developers, and there's 1 million lines of code, and the bug is somewhere. What do? Don't just start staring at code. You'll be there staring at code for the next 6 months until your boss comes and says, what have you been doing for 6 months? Trying to hunt this bug. And your boss will not be happy with you, and you won't get promoted for that. So if I can encourage you, please don't use the bleeding eyeballs technique, even though sometimes it's effective in school. Okay? And when you have a due date that's like tonight, you're going to feel a lot of pressure to get it done, and you might do it, and you know, that stinks. But please try as hard as you can never to find your bugs that way. Find them systematically, even if you know where the bug is, because it's good practice for finding bugs. And if you know how to find bugs, you're worth $100,000 a year, or at least $70,000. I don't know, $60,000 a year. What's the starting salary for a programmer these days? 60? Okay. But the truth is, those are the ones where only half of them can even really code anyway, because they just got their BS degrees. As soon as they find out that you are a good coder, that you really know your stuff and that you can do stuff, and of course you are, because you took my class, your salary is going to go up quickly, or it's going to go up quickly because you're going to leave the company and go somewhere that pays you what you're worth. Be what you're worth. It's awesome to be worth what you, what am I saying? Be awesome and you'll get paid what you're worth. I don't know what I'm saying. Point is, let's learn how to debug. So let's look at the problem. Here's my problem. I can bump into my brick and that's working. But when I try to jump over the brick, I can't seem to get over the darn thing. Okay, we understand the problem? So I want to solve this problem now. Let's launch Eclipse. We could do it with print statements, but that would be more cumbersome. I say we do it with Eclipse, because that's kind of what this assignment's about anyway. Okay. And we have to wait because IBM decided to pack all the dumb tools in this IDE that you could ever imagine. Like EJIT. Don't even know what that is. Still loading EJIT. Now, okay, here we go. By the way, notice this get out method. And notice it's blank. What's up with that? Here's what it is. I wrote that method, but I didn't want to show it to you, so I tabbed it way over to the right so you couldn't see it. Ha ha ha, I'm so clever, aren't I? Okay. I mean, I've got to leave something for you to do yourself, or else what'll happen is students will copy everything off of me, turn it in, and then the next assignment hits, and then all of a sudden they're against a brick wall because they don't know how to do anything. So please try to do as much as you can. And please try to understand this stuff. It really is going to ramp up, and it's going to be important that you get it, not just that you can do it. Doing it doesn't matter. Understanding it matters a lot. So let's run in my debugger. First thing I always do is confirm that the problem still happens in the debugger. Sometimes it doesn't. I'll make this little brick right there, and I'll try to jump over it. And I can't get over it. Ah, that's so frustrating. Get over the brick. I get why I can't go through it this way, but why can't I jump over it? What I want to do is set a breakpoint. Where should I put my breakpoint? It's probably my collision. I agree. That makes sense. Let's do that. So I look at my, where am I? Model. There's my Mario class. Does collide. Probably when it returns true here is where I want to break, don't you think? Okay. But I don't want to I don't want to break right when I bump into the brick. Normally, I only want to break under a special case. So I'm going to add an if statement here that says if y is less than 300, then system.out.println break here. Now, if I write that, is it going to break there? No, the only reason for that line is so that I could come over here and put a breakpoint there. And now it'll break there. So if I run in my debugger, it runs. Here's my game. I make my little brick. And I run into the brick. Notice it didn't hit my breakpoint, even though I collided with the brick. Why not? Because I wrote right there, if y is less than 300, I only want it to hit my breakpoint under the special case where the problem occurs. And now I did hit my breakpoint. You see that? So I made a breakpoint that stopped exactly when the problem situation occurs, which is right in this situation here where Mario is in the air and yet collides with a brick that he shouldn't even collide with because what's going on, right? Well, I got my program in precisely the situation I wanted. And why did I want to get in a situation where something bad occurs? Yeah, this is the, if you can see something bad occurring, then that's the bug, right? So let's look at our code and see, why did you break here? Well, I'm in my does collide method. I stopped right there, and apparently it's about to return true. Should it be returning true? No, that means we've demonstrated the bug, so we just have to figure out why it's returning true. And hey, look, I have underscore x, underscore y, underscore w, and h, and they're all showing up in my watch window. So I have all those numbers. That's darn convenient. But there's also these x, y, w, and h values. Where do I get those from? The ones that don't have underscores.
The position, the height and width and that and the
Yeah, it's the height and width and position of Mario. So the underscore ones are the position of the brick, the way I wrote this code. Where do I get the position of Mario from? Nobody knows? Somebody in the room must know. You see the word this right here? That refers to the object that I am inside of. And if I open that up, here's all the member variables of this. If I scroll up, these are all my member variables, and they should match all these things I see here. There's my y, x, w, and h. Now I can see the location of Mario, and I can see the location of my brick. And I'm trying to figure out what's wrong with this code. Why is it telling me that he collided when obviously he didn't collide?
Because it's meeting the X requirement, even though it's X or Y, not X and Y.
I don't think that's actually it. Let me draw a picture and I'll see if I can prove it. So here's what I have to work with. The brick is at this location, 245, 529, and it has a width of 57 and a height of 46. So basically that means it's about here, and that distance is what? 245. And let's see, the y is 529. Okay, and where's my Mario? My Mario's at x is 195, y is 37. I think that's going to look about like this. 195, 37. Why am I taking the time to draw, diagram this, and write out all the numbers? Because I like wasting time. Because I'm trying to demonstrate, what was this, 195? I'm trying to demonstrate that wrapping your head around a problem is really important for understanding it. Anybody see the bug yet? If you do, you're amazing, because it's not here yet. So here's what I've done, is I've basically shown that these numbers show that they shouldn't be colliding. Don't you agree? They definitely shouldn't be colliding. And it kind of, wait, that's not the right picture. I got two of them open. Go away, old one. There, that's the one that's open. Basically, I just reproduced the same picture that we have right here. The difference is this one is equipped with numbers. Okay, well now let's look at the code and see if it's actually doing what I said to do in my numbers here, which is, oops. Okay, if x plus width is less than or equal to underscore x. So I'm saying if 195 plus the width of Mario, which is 60, what is 195 plus 60? 255? Doesn't that make sense? Because right here we have 245 for the location of the brick, and I'm moving at a rate of 10, so I just barely crossed into the brick by 10, which is exactly the rate Mario moves at. So, hey, I feel good. I understand what's going on right now. Okay, now wait a minute. Why shouldn't it collide? So if you look at this picture, it's actually probably more like this, because he's right there. 195 plus the width of Mario happens to line up with that box right there. Why are they not colliding? Because Mario's clear the heck up there and the brick's clear the heck down here, right? So where in the code does it check for that? I claim it's right here. If y plus height, meaning Mario's y, that's 37, plus Mario's height is 95, is less than or equal to h. See the bug yet? Aha, what should it be? That h should have been underscore y, which is the top part of this brick. And I used underscore h, which is the height of the brick. And so I was really saying, hey, if Mario collided with a position that's equal to the height of that brick, which is way up there. Aha. So basically, you open the debugger, you find a way to get to the problem. Once you're at the problem, you just start bleeding eyeballs, the values, the code. You see what doesn't make sense and what does make sense. Why is that any different than just staring at your code until you find the problem?
Because this actually shows like the value of a certain variable at some point, so you can get an grasp of where the problem actually occurs.
Yeah, I was only staring at this one method. Does collide. That's a lot easier than staring at all of your code, right? When you're working at a company and you've got 500,000 lines of code, if you can just stare at one method until you figure out what's wrong with it, you're doing a whole lot better than if you're staring at their 500,000 lines of code. Okay, so getting to the spot makes a big difference. This underscore h should have been an underscore y. I'm going to change that and hit save. Close my debugger because now I'm done with it. Don't need this picture anymore. And let's build my program, run it again. Here's my Mario. I make a little brick. And now Mario can jump over the brick. Yay! So exciting. And he can't back into the brick, and he can stand on it, and he can come over here, and it looks pretty solid, doesn't it? Let's make a brick up high so we can bash his head onto it. That looks about right. Let's put one right there. Okay, I'm feeling like this is solid. Except I can still jump in the air. That's no good. We want to fix that, and a few other things. But at least at first glance, you kind of get debugging. Any questions about how to debug or how to stop at breakpoints that occur under specific conditions or anything like that? Okay, very important skill. You'll need it. Trust me, coming up.
Can you make the code run line by line?
Can I do what?
The code run line by line?
The goal. You can make the yeah, you can make the code run line by line.
On the game or not really?
So there's a button called step over, and if you just keep pressing it, that's going to run line by line by line, and I think that's the best way to do it. Okay. Let's see. What do we need to do? We did the bricks. I mentioned you need to set the vertical velocity to 0 when you land on top of the brick or when you hit your head on top of the brick. Is it clear why? Because you need to stop him, not just move him.
Is that on when it does collide or when it's like out of the brick?
Basically, when Mario collides and you push him out of the brick, you also need to stop his vertical velocity if he's falling vertically or, yeah. If he hits the brick vertically, he needs to stop vertically. If it's horizontally, you don't need to stop him vertically. That would be weird because then he'd fall from sideways and he'd get stuck to the side of the brick, which that's not what you want.
So after you taking all the brick, you have to start the
Yep. Okay. In fact, let me show you what happens if you don't do that. Okay, model.java. Reload, please. All right, so I'm going to come over here for just a brief moment. Going to rebuild. Here's a brick. If I come over here and jump, do you see how Mario gets stuck under the brick for a little while? Why do you suppose that's happening? I didn't set my vertical velocity to 0 when I hit the brick. So what's actually happening is he's hitting the brick, but his velocity is still going up, going up, going up, and then it comes back down, comes back down. And once he's finally going back down, then Mario falls off of the brick. Similarly, if I jump on top of this thing, all of a sudden he falls through. So it's just not as solid as it ought to be. The answer is I need to set his vertical velocity to 0 when he encounters that brick. Okay. Problem solved there. Let's suppose your Mario's running through the brick and he's just not stopping. What are you going to do about it? Let me show you another trick we can use in programming. So somewhere here we say, in our update, we check for all the bricks and we say, if Mario does collide, then get out. Do we have any way to know if get out actually worked or not? Sure, you try it, you look at it, you see if it worked, right? You can actually do it programmatically too. Meaning, I can repeat my check if it collides and then say system.out.println, oh noes, bad happened. Okay. What is this code here for, and what does it do? Essentially, it does nothing helpful, nothing you really want in your game, but after I've called get out, my Mario should not be inside of the brick, right? So why would I want to see if he's inside of the brick when I already know he's not inside of the brick? Yeah, this is called sanity checking. You want to do all the sanity checking you can in your code. This is what I call self-debugging code. Think about that concept for just a minute. Let the word self-debugging code sink into your mind. And now you realize why you want to write self-debugging code, right? A lot of times programmers feel bad about it. Like there's something terrible about writing code that checks for conditions you already know are true. It's a wonderful thing to do. Yes, it does technically make your computer do a little more work and slightly slows down the program. Whose time is more important, the computer's time or your time? Exactly, right? You're the guy that's been staying up till 4 in the morning working on the dumb program. Who cares if the computer has to do a little bit of work? If it's going to save you 2 hours of time because you're going to run your program and it's going to suddenly print a message that tells you exactly where the bug is, that's totally useful, right? So while you're programming, if ever you have an assumption, if you think, hey, it should be in this condition, or at this point, these values should be greater than 0, or these variables should be, you know, anything like that. For example, maybe right here inside of your Mario, you just want to check and make sure if your width is 0, say, hey, width should not be 0. What would happen if your width was 0? Well, you are non-existently thin, and when you try to collide with things, you'll find you collide with nothing. And basically, a whole bunch of your collision stuff will not happen. But if the moment you created a Mario, it said, oh, wait, you have a 0 width. You must have forgot to initialize it right there. I didn't, so this will never happen. Then all that happens is I waste about a nanosecond of time checking this every single time I run my program. And if I ever introduce a bug that causes Mario's width to be 0, bam, it finds it for me. I didn't even have to debug it. Write self-debugging code. It will make your life much better. So write lots of checks. By the way, better than printing a message is actually this little thing which causes it to kill your program. So while you can print a message and still ignore it, right? Sometimes you print a message and it slides up too fast and you never even see it. So there's another thing called an exception. You can say throw new runtime exception, bad happened. No, that's not proper grammar. I'm trying to be funny. This kind of means print a message too, but it does a few extra things. One, it prints a full call stack that tells you exactly where it was. That's useful for debugging. It prints this message and it kills your program. Do you want your code to crash?
No.
When there's a bug, yes you do. You don't want your code to crash in general, but when you're the one working on your code, you also don't want it to keep working, because that's the worst possible case. You'll never know how to go find your bug and fix it, right? If your code crashes as soon as there's a problem, it's basically saying, hey, fix me. And if your code told you exactly what to fix and where to fix every time there's a bug, then you'll fix it until your code doesn't crash, and then you'll be a very happy programmer. Make sense? So throwing exceptions is a great practice.
Can you show us?
Notice that and do it all the time. Anytime anything happens that shouldn't happen, throw an exception and your code is self-debugging. Yeah.
Can you show us how it works? Can you code the compiler?
Oh, sure. Let's forget to initialize my width. And now I'll build and run my code. Build, Java game, run. Immediately it crashes. Exception in thread main. Java lang runtime exception. Bad happened. At mario.init, that means it's the constructor, which was called from model.init, the model's constructor, which was called from the game constructor, which was called from main. So what you're seeing is a call stack to where the problem occurred and what the problem happened. And you'll just look here at model.java line 20. You'll go straight to line 20 and say, oh, that's what happened, that thing right there.
So end means constructor?
This is the constructor because it's the same, the method has the same name as the class.
Yeah, no, but you mean the end.
The int. Where it says init, that's kind of magic internal lingo for constructor. I don't know why they say that. I wish they would have just said Mario.Mario instead of initialize, but well, init is kind of the internal name for the constructor, and the code name for the constructor is the same name as the class. So now you know init means constructor. Okay, and you've just learned how to write self-debugging code. By contrast, if I do a system.out.println, let me show you why this is not as awesome. Build, run, my program pops up, I play for a while, I think everything's good. No messages here, all is well. But way up here, this was this message that just happened to be there, and apparently I printed a bunch of blank lines for some reason.
Yeah, what does that mean?
When he doesn't collide with the...
I don't know, I printed blank lines somewhere, I'm not sure where.
when he doesn't collide.
Oh yeah, when he doesn't collide, I print right here.
No. When he collides with first message and when he doesn't collide.
Oh, that's right, I forgot this line because I added that before. By the way, if you've got this in your code, you probably want to remove it. That was me debugging it, and I'm not telling you do exactly what I do. I'm trying to teach concepts. So just so you know, I'm not going to take you much further in actual code. I'm going to start teaching by writing example code hereafter and not compiling it for you. And you need to be able to understand and translate this into your program, because slowly I'm going to stop holding your hand and make you stand on your own. Okay. In fact, just before we do that, let's do one other issue. How about scrolling? So, I'm gonna run my game. Here's Mario. Mario runs. It looks, what? Oh, because he has no width. Ha ha ha. Okay. I created a bug and I didn't even fix it. Build, run, okay. It feels like a game, but everybody knows Mario doesn't move. The screen's supposed to move, right? Okay. Thank you for responding to me. I feel so alone when I just talk to myself. Okay. So let's just, how about in our view.update or paint components? How about every time we draw the screen, we say model.scroll post plus plus. So basically I'm saying just scroll. See what that's like. So you know that Mario, oh dear, have view issues. That's not awesome. You know how in some versions of Mario the screen's just constantly scrolling? Hey, there it is. I found the magical brick that's differing from where it's drawn. Okay, well that's no good. We have another issue to debug. Shall we debug it? Okay. Anybody else doing that? Yours is doing that too? Okay, well that's not okay. So we need to figure out what it is. Wow, we hit break here quite a bit.
Mario at scroll post as well.
Let's,
X minus scroll post.
yeah, I actually know what this issue is. Can I just show you, or do you want to debug it with me? I'll just show you. Okay, look where I'm drawing my brick. At brick.x minus the scroll position, brick.y, and width and height. Look where I'm drawing my Mario. Mario X, Mario Y, null. You see the problem? Basically, I didn't subtract model.scroll posts from my Mario's X position. So the brick was actually being drawn in the correct place. Mario was being drawn in model coordinates on the view. Don't get view coordinates mixed up with model coordinates. If you do, weird happens. You with me? Okay. Well, let's see if I fixed anything. Build Java game. There goes Mario. Hey, get back on the screen. Okay. So there are Mario levels where, hey, it's solid. That's good. Where you're constantly scrolling, and that's great. But most Mario levels are not just scrolling at a regular rate. Most of them just scroll at the rate of Mario, and so you're always with Mario. Let's do that instead. How can we make it so instead of moving at a steady rate, we're moving it however fast Mario goes?
Do we have to make Mario static?
Don't need to make Mario static.
Just in control when you're using
equals to Mario's,
in control when you're moving Mario left or right. You can also act as scroll post.
Yeah, it's actually pretty simple. Let's just lock the scroll position to Mario's position. Scroll post equals X. That's it. Right? See if that works. That doesn't work. It will. We'll fix that next. I'm pretending I don't know that so I can...
I think scroll post is model.
Oh, it's in my model. Model dots. Mario happens to know about the model, so that's easy. Okay, I build it, I run it, and now let's draw a brick and another one up here. Hey, that feels more like Mario, doesn't it? Except, you know, he's kind of squished against the back, isn't he? How about we attach the scroll position to Mario X minus what? 222. Because that's a good number. Okay, I build, I run, push it onto the right screen. Okay. Hey, now it's scrolling with him. Oh look, when I hit my head on this one, I can fall through that one. Woohoo, I found a bug. So that kind of issue is the kind of issue where I'm just going to wave my hands and say, good enough, I don't care. If you were building a game that you were making money for, you'd probably have testers who are going to test your code, and then they'll push onto you bugs, and you have to fix them, and you'll have to go get those cases working. And yeah, that'll probably result in some complex code to deal with that. But hey, now it feels like a game, except for the fact that Mario can fly. That's totally lame. How are we going to fix that? So let me point out something else about my instructions. Firefox. Paradigms. Schedule. What is it, assignment 3? Okay. Make a side-scroller game, add gravity, make brick stop Mario, enable Mario to jump. Add a counter that counts the number of frames since Mario last stood on something solid. Do you know how to do that? Okay, I better show you how. Set it to 0 when Mario stands on something solid again. If this counter is less than, say, 5 and the spacebar is pressed, accelerate upward by subtracting some number from Mario's vertical velocity. What am I doing there? Do you remember original Mario, how you hold the little paddle and you push the button and Mario jumps, right? But what does everybody really do? They go like this. Every time you want Mario to jump, you just naturally go, come on, jump, right? Because you feel like in your heart, here, we'll pretend this is the paddle. If you go like that, Mario's going to jump. And people get a lot of ruined paddles because when it's important, right, there's a bunch of turtles coming at you and you're in panic. You smash really hard because you just really want Mario to jump. I'm not going to break my mouse for you, but people do that. Well, it used to drive me nuts because I used to be an avid game player when I was young, and when people would go like this when they were doing the controls, I used to say to them, it doesn't make a difference. So you know what they did? They took the paddles and they put accelerometers in them, and now it does make a difference. Drives me nuts. They also made it so that when you hold the button down longer, that means they're pushing really hard probably, right? And so with Mario, you'll find if you hold the button down longer, he actually jumps higher, and if you hold the button down not very long, he doesn't jump very high. How does that work, do you think? Yeah, well, basically, I'm asking you to do that just because, hey, it's something to do. So here's how that works. If they just tap the button one time and say you subtract some number, 6, from the velocity, what's going to happen? It's going to go boing. What happens if you subtract 6, but they're still holding down the button? You subtract more, and now they're moving up at a rate of 12. And if they're still holding down the button, now they're moving up at a rate of 18, right? And so now it'll shoot up really high. What if they're still holding down the button? Well, at some point, you got to back down and say, you're not standing on the ground anymore. You don't get to keep jumping. Otherwise, Mario could shoot up into space by just holding down the button. So are you visualizing in your head what the code's going to look like? We kind of want to say, hey, if you've been on the ground in the last k seconds, where k is some number like 5 or 3, or you pick what number, then we're going to keep accelerating. So while the button is down, accelerate, 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 and then just let it go, man, because he's going to fly and arc back down. And if Mario's falling from the sky and you push the button, should he be able to jump? No, because he hasn't been on the ground recently. So think about it as a counter that counts how many frames it's been since he's been on the ground. Let's write one. So here's my model. How about int frames since I last stood on solid ground equals 0. That's a great variable name. You don't have to call yours that. In fact, I recommend you don't. Now, instead of initializing it right there, I'm going to initialize it right here, because it's actually better to initialize things in the constructor. I'll talk about why later, usually. Sometimes it's not, but okay. So there we go. How long has it been since he stood on solid ground? Well, in my update method, let's just make it tick away. Do you see how this is going to make it be 0, 1, 2, 3, 4, 5, 6, 7, 8? Every frame we're going to increment the number, so now it gets bigger. But how do I know when he stood on solid ground? Well, right here, remember if y is more than 500, y equals 500, let's reset it back to 0. Do you see how now the counter is how long it's been since he's been on the ground? I better add some comments because this is getting yucky. Stop when Mario hits the ground. In a real game, you probably wouldn't have a special hard-coded ground. You'd just have bricks. And you'd build a map that had bricks all along the ground so that when you didn't have ground, he'd just fall through in a pit, right? So you can get rid of the ground if you want to. What I'd like you to do in this assignment, or at least by the next one, is, well, no, do it this one. When your game first starts, don't have a blank screen. Have some bricks already there. So in your constructor or somewhere when it just very first starts up, not the Mario constructor, maybe the model constructor, load some model that you have already made from a file. That way, it's actually more like a game. The grader is going to expect this to be a game, not a map editor. So the whole reason we made a map editor is so you could make a map, right? But the grader just wants to play a game. So as soon as it starts, there should be bricks all over the place, and Mario should just start running on the bricks. Okay? Well, why was I talking about that? I was trying to do frames since you last jumped. Okay, now we know how long it's been since Mario stood on the ground. What should we do with that? Let's go to the controller. And somewhere in here, if Mario hits the space bar, wow, we set its velocity to -40. How about this? If model.mario.frame since I last stood on solid ground is less than what? 5, 4, 5. Then instead of setting it equal to -40, how about minus equals 10.1, because I can. Now we see what happens. Build Java board game. Okay, so ready, jump. It's not working. What? Okay. Wow, that's embarrassing me. Let's try that one more time. I don't know what's going on there. There's a brick. Jump. We got nothing. Okay, go. All right, this is a big mystery. I know the places I've changed recently. There's not too many spots, so I'm going to use the approach I told you never to use and just stare at those spots for a minute and see if I can see it. If we held down the space and he's recently been on the ground, then make his velocity more upward. That looks right. Model. Okay, we set it to 0 at the start. When he hits the ground, we set it back to 0.
Is it because we're always
And we increment it.
the update instead of increasing it on condition?
So it's true we're always counting up how many frames it's been since he stood on the ground, but he should have 5 frames since he touched the ground to get up there. Ah, I bet you that's it. If y is more than 500, we set it to 500 and stop him. But at that moment, is y more than 500? No, it's equal to 500, so we're not going to set it back to 0. So what if I say more than or equal to? You think that'll fix it? It's a hypothesis. Let's try it. Okay. I usually like to know what I'm doing rather than just try stuff, but wow, that's a tiny brick I made.
Now you can't jump at all.
Yeah, I cannot jump at all. Well, I'm slightly embarrassed. I honestly don't know what's going on. I guess we could debug it, or we could just back away and say I've kind of shown you this and move on to the next topic. What do you think? Yeah, I got a thumb up for that. You guys feel like you understand how to make him jump when he's been recently on the ground? I got one, debug it. Okay. Let's see, right now it's 4:30. We are here till 4:45? Yeah. I got a few topics I got to cover. I'm going to talk about the other topics because I need to. We'll come back and debug this because we need to do that too. All right, now we're in fast mode. Let's go quickly. Let's start by talking about lazy loading. I've got a view here. In my view, I've got a Mario image. Now, as it happens, these images are loaded every single time I create a view. Now that's okay because there's only one view in this entire game. But if I made two views, it would end up loading a whole bunch of times. Do you see that? Okay. I'm going to do something different. I'm going to make this static. What does static mean? That means there's only one of them no matter what. No matter how many views I make, there's only one of these things. But still, every time I make a view, it's still going to load them all. Do you see that? Unless I say, starts off at null, and if Mario images is null, then load all those images. Voila, I have done lazy loading. Okay, let's talk about what we did. If I were to make 10 views, what would happen? The very first one would get to right here, and will the Mario images be null? Yes, they will, because they were initialized to be null. And so it would allocate that array, and it would load all 5 images into the array, and there we go. The next time I make a view, I don't know why I would have 2 views, but suppose I did, then would Mario images be null? No, because there's only one Mario images variable, so it would be non-null. And because it was non-null, we would skip all of this code and we would not load it again. This is called lazy loading. I have lazily done it because you use this type of a structure when you don't want to do anything until the last possible moment. And when you do that, you always use an if statement to make sure it doesn't happen every time. Every year, somebody loads their Mario pictures inside the paint component method. What do you think? How does that look? Well, if you have lazy loading, where you're checking if it's null or not, then it will only happen the first time, and then that's actually okay. But if you omit the if statement, and you just load the images from disk every single frame, basically, your hard drive is going to go crazy, your computer is going to get overwhelmed, your CPU fan's going to start spinning, and your game's going to be at a crawling pace. And yeah, people have that, and it's a really nasty issue. So make sure your images are loaded only once. Lazy loading is a great way to ensure something cannot happen more than once. So there, we've done lazy loading. Do you get it?
Yes, I understand.
Lazy loading is a great way to make sure something happens only once. And this is how you do lazy loading. Make it static so there's only one of them. Use an if statement to make sure it's never loaded more than once. Okay. Check off the list. Next, I need to do iterators, and then we'll go debug that problem that I just created. Okay. Anybody ever heard of an iterator before? We got one. Okay. Java array, well, I'll just show you what an iterator is. Let's go to our model. Model update. Okay, right here, I am iterating over all of the bricks in my model. I'm using a for loop. I'm saying I starts at 0, and it goes for however many bricks there are, I++. You all get for loops, right? Okay, this is one way to do it. This way only works with array lists. There are other types of collections in Java, such as linked lists. You guys know what a linked list is? Awesome. What happens if you try to index a linked list by its index? You actually can in Java, but it's slow. Imagine if your linked list had 10,000 elements in it, and you say, get me the 9,998th element. What does it do? It has to start at the beginning and go to the next one, go to the next one, go to the next one. It takes a darn long time. Well, if you did this type of a loop with a linked list, it would be unbearably inefficient. Okay, there is in Java a thing called an iterator. Here's how you do it. You say iterator, and I'm iterating over brick. So it's an iterator of brick. It equals model.bricks.iterator. Basically, model.bricks is an array list. And all collections in Java have a method named iterator, which returns to you an iterator of the type that your collection was storing. Well, an iterator happens to have a method in it called hasNext, I think. So you can say, while it.hasNext, and then you can say it.next.
The question, so the
And you can say brick b equals it.next. So what this does is this visits all of the bricks in your collection. It does the same thing as that bit of code that you see here. So this is using an iterator, this is using a for loop. They both do the same thing. Okay, question?
what is the goal?
What is the goal? That's my next question. So I just showed you how to do it, but now why? Why did I do that? In fact, this is less code. I only use 2 lines of code here, and I used 3 whole lines of code here. So why is the iterator version preferred over the for loop version? I did already kind of say the answer. Faster? Turns out, no, it's actually not faster with array lists. Yeah.
So you can like iterate over different types of like arrays or linked lists without having to really like, having a specialized case for each of them.
Yep, that's the reason. So basically, if you came along later and said, oh man, I'm using an array list, but gee, I wish I had used a linked list. Don't know why you would, but if that happened, you could just switch to a linked list and the code would still just work. And it would still be efficient. If you switched this bricks from an array list to a linked list and used this approach, it would suddenly come to a crawling halt because getting from a linked list by index is really, really slow. Iterators are designed to be agnostic to the type of collection. There are other types of collections besides array lists and linked lists. There's also tree sets and tree maps and hash sets and other things. And it would be kind of nice if your code was general purpose, wouldn't it? One of the principles we're going to emphasize as sort of a programming paradigm is try your darndest to write code that's general purpose. So if you use an iterator instead of a loop, well, then your code is just ready to have the stuff changed underneath it without it being brittle. If you use the for loops, this is assuming you're using an array list. And if you know you're going to use an array list, go for it. If you want something that just works with any collection, then use an iterator. Why do you need to use an iterator in this assignment? Because it's one of the requirements and I said so. That's it. You have to have some experience using an iterator. This is how you do it. Now go use an iterator. Yeah.
So now when you iterator and then brick, is the brick is the name?
Brick B, this brick is the type, B is the name. it.next gets the next thing in the collection out of the collection and returns it. Did I answer the question?
Wait, then again the IT next mean like go to the next level.
So this is the type of my iterator. This is the name of my iterator. This is the method that tells this is my collection. This tells my collection, hey, give me an iterator over you. An iterator is an object that knows how to visit all the elements in the collection. This is my loop. And as long as there's something left in my iterator, here's me saying, get me the next thing in the collection, and this is what it gives me, is that brick that I'm storing in B.
Okay, so the brick it might change to something else.
It will always be a brick because this iterator only visits bricks.
Okay, but the brick I can do that. It could change to something.
If you had a collection of something other than bricks, if you had a collection of Goombas, you could iterate over Goombas just as well. But yeah, whatever the collection is storing is what the iterator also will return to you. Okay, let's prove this works by deleting my for loop and showing that my code still works. Oh wait, except my code doesn't work. For right now, I'm going to go to my controller and get rid of this if statement. I think that'll fix it. And hopefully we'll make it all work. Then we'll go debug that problem, and then we'll be somewhere. What's going on? Die, program. Wow. Okay, die for real. Die. I'm showing you the Linux command for I'm angry, do it or die. Oops. I don't know what I killed, but okay. Here we go. I now have a game. There's my brick. It's running. I can't seem to jump. So somehow I broke my jumping, but I think I'm running. Yeah, it's still drawing my bricks, and that's what oh no, that was collision with the bricks. Let's see if I can still collide with my bricks. Yep, I can still collide with my bricks. That means that code is working. That means that my iterator just worked. Oh, but I closed it. Okay, model.java. Oh no, you saw the code I wanted you to hide, not see. Commercial. Oh, where am I? I used my recover data. I'm not even confident it rebuilt. It didn't rebuild. Cannot find symbol iterator. Okay, we're going to have to Google for Java iterator. Is it Java util? There it is, java.util. So I'm going to come up here and say import java.util.iterator. We have never seen if this works yet. Now we'll find out. Java game. Okay, it works. I still can't jump, but he can hit the bricks, which means my iterator is working. So now you know how to do that part of the assignment. Okay, I think I've covered everything you need to know, except for my jumping system isn't working because I did something wrong, and now we've got to figure out what that is. So, okay, let's see. Usually pretty good under pressure programming tests, but I honestly don't know what it is right now. Let's find out if the space key is even being recognized. System.out.println, hit the space key. See what I'm doing? I'm trying to find out, is it even getting to that point? Because it's not working. I got to know if I have anything to work with here. So I hit space key. Whoa. That is weird. Weird juju. Okay, I know it's getting to this point. When it does, I'm going to set Mario's vertical velocity to -10. It used to be -40, something like that, right? Let's see if this restores everything. That's pretty much how it used to be. I think we're good. Okay, now let's sign in. What? Weird stuff today is happening. Okay. Let's say only if he has recently stood on the ground can we jump. The game. I can no longer fly. Yay! But I can no longer jump off of a brick either. How am I going to fix that? Basically, when I collide with a brick vertically and it pushes me upward, I need to set frames since I've been on the ground to 0. Does that make sense? Okay, good deal. Then, that minus equals thing, that really should have worked, but that's clearly the problem, so apparently that's what not to do. Yeah, I know what it is. I have solved it in my head. Okay, here we go. Here's my problem. Right here, when I set y to, when y is more than 500 and I move him back to 500, what did I forget to do? I forgot to set my vertical velocity to 0. So he was on the ground, but he was falling faster and faster and faster and faster. So when I hit spacebar and I only subtracted 10 from his velocity, instead of moving down at 500,000 miles per hour, he was now moving down at 499,990 miles per hour. Get it? Okay, by now setting his vertical velocity to 0, subtracting 10 from this thing will actually work. Haha, and I did it just in the nick of time because class is almost over. And now he can jump, and I can do little jumps and big jumps, but I can't fly. Perfect, now you can do everything in the assignment. Awesome, thanks for coming, have a good day.